Hello viewers, in today's class we are going to discuss a very interesting problem from limits, right? So in this lecture we'll see how we can evaluate this limit where we have a limit extends to 0, and here we have natural log, that is the log of 1 plus x square up to x raised to n divided by n times x, right? So in this lecture we'll see how we can evaluate this limit by using a standard result from limits involving the logarithmic limit, right? So let us start. So viewers, let us take this limit as L, right? And here what we will do, we'll write limit extends to 0, and let us concentrate on this expression, right? So here we have x plus x square plus up to x raised to n, right? And let us assume this term as theta, right? So now we can write this limit as log of 1 plus theta and divided by nx, right? So here we are using theta just for our convenience, and here we can see that when x tends to 0, then all these terms disappears, and theta also tends to 0, right? So here we'll assume theta is equal to x plus x square up to x raised to n, right? So now let us write this limit as the limit. Here we have x tends to 0. So when x tends to 0, we have theta tends to 0. So here we can write theta tends to 0, log of 1 plus theta. And now see, here we have a term containing x, right? That is nx. So what we will do, let us multiply the numerator and denominator by this term theta, right? So here we can write theta, then here we can write theta, and in the denominator we have nx, right? So here theta and theta get cancelled. So what we have done here, we have multiplied the numerator and denominator by this term theta, right? Now let us concentrate on this limit, right? So from standard result from limits, we know that limit theta tends to 0, log of 1 plus theta divided by theta is equal to 1, right? So now this limit is equal to 1, and we have limit theta tends to 0, and here we have theta over nx, right? So now see, we can write limit theta tends to 0, theta over nx. Now let us change this expression again in terms of x by replacing theta by this term, right? So we can now replace theta tends to 0 by x tends to 0. So we have x tends to 0, and theta is x plus x square up to x raised to n, and here we have nx, right? So now if we take x common in the numerator, we have x 1 plus x plus up to x raised to n minus 1, right? And in the denominator we have an x. So x and x get cancelled, so we are left with limit x tends to 0, 1 plus x up to x raised to n minus 1 divided by n, right? Now see, when x goes to 0, then this entire term becomes 0, right? So we have 1 plus 0 divided by n, that is equal to 1 over n, right? So viewers, the value of this limit is equal to 1 over n.